At the end of this video, you should be able to explain the gas, liquid, and solid states in terms of particles, and distinguish between a mixture and a pure substance. Melting and boiling are part of an important class of physical changes called changes of state. As the name suggests, a change of state is a physical change of a substance from one state to another. The three common states of matter are solid, liquid, and gas. Matter in the solid state has a definite volume and a definite shape. For example, a piece of quartz or coal keeps its size and its shape regardless of the container it is in. Solids have this characteristic because their particles are packed together in relatively fixed positions. The particles are held close together by strong attractive forces between them and only vibrate around fixed points. Matter in the liquid state has a definite volume but an indefinite shape. A liquid assumes the shape of its container. For example, a given quantity of liquid water takes up a definite amount of space, but the water takes the shape of its container. Liquids have this characteristic because the particles in them are close together but can move past one another. The particles in a liquid move more rapidly than those in a solid. This causes them to overcome temporarily the attractive forces between them, allowing the liquid to flow. Matter in the gas state has neither definite volume nor definite shape. For example, a given quantity of helium expands to fill any size container and takes the shape of the container. All gases have this characteristic because they are composed of particles that move very rapidly and are at great distances from one another compared to the particles of liquids and solids. At these great distances, the attractive forces between gas particles are much weaker than those in liquids and solids. An important fourth state of matter is plasma. Plasma is a high-temperature physical state of matter in which atoms lose their electrons, which you may know about from your earlier work in physical sciences. Plasma is found in a fluorescent bulb, for example. Melting, the change from solid to liquid, is an example of a change of state. Boiling is a change of state from liquid to gas. Freezing, the opposite of melting, is the change from a liquid to a solid. A change of state does not affect the identity of the substance. For example, when ice melts to liquid water and when liquid water boils to form water vapor, the same substance, water, is still present. The water is simply changed in state, but it does not turn into a different compound. Only the distances and interactions between the particles that make up water have changed.
A solid has definite volume and definite shape. The particles of a solid vibrate in fixed positions and are held in place by strong, attractive forces between them. A liquid has a definite volume but not a definite shape. The particles of a liquid have a range of movement that allows them to slide past one another. A gas does not have a definite volume or shape. The particles of a gas move fast enough to overcome nearly all of the attractive forces between them. Gas particles move independently of one another.
When physical or chemical changes occur, energy is always involved. The energy can take several different forms, such as light or heat. Sometimes heat provides enough energy to cause a physical change, as in the melting of ice. And sometimes heat provides enough energy to cause a chemical change, as in the decomposition of water vapor to form oxygen gas and hydrogen gas. But the boundary between physical and chemical changes isn't always so clear. For example, while most chemists would consider the dissolving of sucrose in water to be a physical change, many chemists would consider the dissolving of table salt in water to be a chemical change. As you learn more about the structure of matter, you will better understand why the boundaries between chemical and physical changes can be confusing. The variety of forms in which matter exists is enormous. However, all matter can be classified into one of two groups: pure substances or mixtures. A pure substance can be an element or compound. The composition of a pure substance is the same throughout and does not vary from sample to sample. Mixtures, in contrast, contain more than one substance. They can vary in composition and properties from sample to sample, and sometimes from one part of a sample to another part of the same sample. All matter, whether it is a pure substance or a mixture, can be classified in terms of uniformity of composition and properties of a given sample. The figure on the screen here illustrates the overall classification of matter into elements, compounds, and mixtures. You deal with mixtures every day. Nearly every object around you, including most things you eat and drink, and even the air you breathe, is a mixture. A mixture is a blend of two or more kinds of matter, each of which retains its own identity and properties. The parts or components of a mixture are simply mixed together physically and can usually be separated. As a result, the properties of a mixture are a combination of the properties of its components. Because mixtures can contain various amounts of different substances, a mixture's composition must be specified. This is often done in terms of percentage by mass or by volume. For example, a mixture might be 5% sodium chloride and 95% water by mass. Some mixtures are uniform in composition. That is, they are said to be homogeneous. They have the same proportion of components throughout. Homogeneous mixtures are also called solutions. A salt-water solution is an example of such a mixture. Other mixtures are not uniform throughout. That is to say that they are heterogeneous. For example, a mixture of clay and water, heavier clay particles within the mixture concentrate near the bottom of the container. Some mixtures can be separated by filtration or vaporized to separate the different components. Filtration can be used to separate a mixture of solid barium chromate from the other substances, such as the one shown on the screen here. The yellow barium compound is trapped by the filter paper, but the solution passes through. If the solid in a liquid-solid mixture settles to the bottom of the container, the liquid can be carefully poured off, also known as decanted. A centrifuge, which is also shown on the screen here in the middle, can be used to separate some solid-liquid mixtures, such as those in blood. Another technique, called paper chromatography, can be used to separate mixtures of dyes or pigments because the different substances will move at different rates on the paper, as is shown on the right side of the screen here. In contrast to a mixture, a pure substance is a homogeneous single entity. A pure substance has a fixed composition and differs from a mixture in the following ways. 1. Every sample of a given pure substance has exactly the same characteristic properties. All samples of a pure substance have the same characteristic physical and chemical properties. These properties are so specific that they can be used to identify the substance. In contrast, the properties of a mixture depend on the relative amounts of the mixture's components. 2. Every sample of a given pure substance has exactly the same composition. Unlike mixtures, all samples of a pure substance have the same makeup. For example, pure water is always 11.2% hydrogen and 88.8% oxygen by mass. Pure substances are either compounds or elements. A compound can be decomposed or broken down into two or more simpler compounds or elements by a chemical change. Water is a compound made of hydrogen and oxygen chemically bonded to form a single substance. Water can be broken down into hydrogen and oxygen through a chemical reaction called electrolysis, which is represented on the screen here to the left. Sucrose is made of carbon, hydrogen, and oxygen. Sucrose breaks down to form other substances like the ones shown on the right side of the screen here. Under intense burning and heating, sucrose breaks down to produce carbon and water. The chemicals in laboratories are generally treated as if they are pure. However, all chemicals have some impurities. Chemical grades of purity are listed on the screen here as an example. The purity ranking of the grades can vary when agencies differ in their standards. For some chemicals, the USP grade may specify higher purity than the CP grade. For other chemicals, the opposite may be true. However, the primary standard reagent grade is always purer than the technical grade for the same chemical. Chemists need to be aware of the kinds of impurities in a reagent because impurities could affect the results of the reaction. For example, the chemical label shown on the screen here shows the impurities for that grade. The chemical manufacturer must ensure that the standards set for the reagent by the American Chemical Society are met. At this point, you should be able to explain the gas, liquid, and solid states in terms of particles, and distinguish between a mixture and a pure substance.